them, and the logarithm is defined as the the inverse operation of the exponential function. And to write the inverse, we want to just make sure that we understand that we have a base of the exponent is the base of the log. The exponent is always so at the log equals to, and the output of the exponent is the input of the log, okay, which we call the argument of the log. So these are equivalent expressions. These two things are exactly the same thing. One is expressed as an exponent, the other expressed as a log, but they actually mean the same thing. And I'll give you an analogy here. We have something like this: sine theta equals x. Okay, this expression here, this is our ratio x, this is our angle theta. We can rewrite that with an inverse operation, and we say the sine of the ratio is equal to the angle theta. Okay, so this is an equivalent translation of the function and its inverse. Okay, so that's what we've done here. We are just rewriting the exponential as a log. Okay, and we want to make sure that we are able to translate between the two. So when we look at the exponent is a function that, our exponential function is this blue one here. It's got a horizontal asymptote, goes through like this. It's got a point right here at 0, 1. If we think of a log, okay, actually before I get into the log, this is our exponent y equals a to the x. This is an equivalent expression in the log form. Okay, so the base. The y output is my input. My exponent is the answer to the log. So that's we haven't done any inverses here. If we want to inverse something, we switch the x and y. So this is my inverse expression, and that will give us a red graph. Okay, and the red graph has a vertical asymptote, and it has a point at 1, 0. Okay, it is a mirror image across that line y equals x. Now, what we want to be able to do is rewrite this in terms of the log form. Okay, so we want my output y, my input is x, and the base is always going to be a. So the log and exponential functions are just inverse of each other. And if we want to do an inverse operation, we need to apply the log, and that gives us this inverse, this mirror image across the line y equals x. So again, we really want to make sure that we are clear how we can write a log before we actually use the log. Okay, so we want to be able to write the log. Okay, this exponential form has an equivalent log form. In the log form, the base has to stay the same. But for logs, the log always is equal to the exponent. And then my input is going to be the output of my exponential expression. Okay, so here I have log. The base has to be, be careful with this base, the base has to be the whole base, okay, because it's in brackets. So my base is 3a. My exponent here is the x value. And then my input has to be the output of the log. Okay, so that's log base 3a of y equals exponent x. Here, this is different. It looks the same, but it's different. This base is not base a. Okay, so before we can write it into a log, we need to have the 3 parts of this. We need a base, an exponent, and the argument or the output. Here we have a base, exponent, the output, but we also have something, a times here, which doesn't fit into our exponential expression. And it's different than here because it's not in the bracket, so that's not part of the base. So what I have to do first is I need to rewrite this without the times 3 on this side. So now I can see that I have a base, exponent, and an answer to that exponential expression. Now I can write this in terms of logs. Okay, so there's my base a. I know it equals my exponent. My exponent is x. And then now my argument or my input is the answer to that exponential expression. Okay, an exponential expression can have this extra 3 in front of it. We need to move that 3 to the other side first. Okay, so here we have again, we have a base, an exponent, and an answer. That's okay. That's in the right form. So I'm going to go log. My base is going to be that whole thing there. My exponent is going to be that whole expression here. And then my argument is going to be my answer to the exponential expression. So my output here is my input here. Okay, there's my, and it gives me the answer of the exponent.